Hello everyone, I'm Jeevan Raj, a certified data science and analytics coach working at Imarticus Learning. Today we'll be starting a new topic on ANOVA test. So we'll be dealing what is ANOVA test and what are the various types of ANOVA test and why you want to choose ANOVA test. So without further ado, we'll go for today's agenda. So at the end of the session, you will be learning what is ANOVA test and implementation of One Way Anova, understand the assumptions of ANOVA test and implement the post-hoc test. What is the purpose of using post-hoc test, type of ANOVA test and the applications of it. So introduction to ANOVA test. So ANOVA test is nothing but an analysis of variance test. It is used for the statistical method used to determine whether there is a statistical significance difference between the mean or not. So it is used when there is 3 or more independent groups, or we call it as classes. It is particularly useful when comparing the multiple groups to understand if at least one group has the significance difference or not. So I've been used t-test and z-test before, right? So whenever you use t-test or z-test, for an example, we are comparing one categorical variable with one numerical variable. Consider your target variable is continuous in data, whereas your numerical is categorical in nature. So in the categorical data, if there is only two levels or two groups, you go for t-test. So when to use t-test? When you don't know the population standard deviation or if the sample size is less than 30. At that particular time, you would have used t-test. So what if the case, if there is more than two groups or if there is three groups, at that particular time, you want to choose ANOVA test. What are the key components of ANOVA test? The major key components of ANOVA test are hypothesis. So what is hypothesis here? Hypothesis is nothing but it is a mutual exclusive statement on the population using sample. So what is mutual exclusive statement? So I hope you have already heard about this mutual exclusive statement. Mutual exclusive statement is nothing but either only one event occurs. For example, both the event cannot occur on the same time. That is called mutual exclusive event. If you ask me, give me an example for it, I can say tossing a coin. Tossing a coin is a mutual exclusive statement where both head and tail cannot occur on the same time, right? So the same way, in the hypothesis testing, null hypothesis and alternative hypothesis cannot occur on the same time. The null hypothesis in ANOVA test states that assume that all the group means are equal. Alternative hypothesis states that assume that at least one group of means having a different analysis. So there are various types of ANOVA test: one way ANOVA test, two way ANOVA test, and we have multiple ways. We'll try to understand in detail of what are the various types of ANOVA test in going forward. So what is one way ANOVA? One way ANOVA test is nothing but compares the means across one independent variable. Example, test score of the students from the different school. Two way ANOVA. Two way ANOVA comprises that means across the two independent variable and can also access the interaction effects between them. For example, the effects of different teaching methods of the student and as well as along with that genders on the test score. This is where two way ANOVA. We'll do practical understanding so that your understanding will be much more clearer compared to theoretical stuff. We also have F statistics. F statistics is nothing but in the ANOVA test, it calculates the F statistics, which is the ratio of variance between the group to the variance within the group. A large F statistics indicates the group's means are not equal. And we also have p-value. P-value is very most important. This will be the deciding factor whether to accept or reject the null hypothesis. Whereas p-value in the ANOVA test is that it produces the p-value that helps to determine the significance of the result. If the p-value is below predetermined threshold values or level of significance, we reject the null hypothesis, else we accept the null hypothesis. So as I mentioned, p-value will be the deciding factor. If it is less than level of significance, we reject the null hypothesis. If it is greater than the level of significance, we fail to reject the null hypothesis. So ANOVA is oftenly used for feature selection to identify which feature contributes significance to vary in the target variable. By using ANOVA test, you can access whether the mean of different groups formed by categorical variable are significantly different and thus decide which features to retain or which features to discard. It can also be used in context of model evaluation. When comparing the performance of the multiple model across the different datasets, you can use ANOVA test for the configuration purpose. What are the example and use case of using ANOVA test? Suppose you want to test the effectiveness of the three diets. For example, consider there is a three diets that is going on, diet A, diet B and diet C. So you want to understand which diets will help you to lose your weight. You collect the weight loss data from the participants on each diet and form one-way ANOVA test. If the test shows the significance difference, you can conclude that at least one diet is more effective than the other diet. So this is where ANOVA test will help. So if you also want to understand which test was helpful, or for example, which diet was more effective, at that particular case, you can go for post-hoc test. So the majorly used post-hoc test is Tucky HST, honesty in significance difference. We'll be discussing that in the later on session. So what are the types of ANOVA test? As I mentioned, we have four major types of ANOVA test. First one is one-way ANOVA, two-way ANOVA, N-way ANOVA and Manova test, that is multivariate analysis of variance. What is one-way ANOVA? A one-way ANOVA test is nothing but a test is used to test the equality of means of two populations. To test the equality of more than two population, we are using the one-way analysis of variance. For an example, consider you have the salary with high school, graduate and postgraduate. At that particular time, you go for one-way ANOVA. For an example, what will be your null hypothesis and alternative hypothesis for this? Your null hypothesis states that the average salary for each group is equal. That means the average salary of the high school person, the average salary of graduate and the average salary of postgraduate are earning the same. The alternate hypothesis states that at least one pair of group are earning the different salary. For an example, either a high school and graduate are earning different salary, or high school and postgraduates are earning different salary, or postgraduate and graduates are earning the different salary. So, I hope everyone understood what is one-way ANOVA. It is used when the one variable is continuous and the other one is categorical in nature. The total variation and simple observations is split into different components. Each component gives the estimator of population variance. The ANOVA is based out of F distribution, whereas I also know that T test is based out of T distribution and Z test is based out of normal distribution. The same way, ANOVA is based on F distribution. The total variation in the simple observation is split into different components. Each component gives an estimator of population variance. For one-way ANOVA, the components are within group variation between the group variation. Thus, the total variation between the group variation plus within group variations. The assumptions of ANOVA test are: the experimental errors should be normally distributed. The samples from the normal distribution or from the normal population which equals to the variance. For example, we are talking about the homogeneity. There should be constant variance. The samples must be independent. That means the observation to be independent to each other. The same way when we do the assumptions of linear regression, there in the linear regression also we have the assumption called homogeneity and independence of observation. Homogeneity means there should be constant variance of error, and independence of observation, the observation to be independent to each other. What about two-way ANOVA? Two-way ANOVA is nothing but two-way ANOVA extends the one-way ANOVA by comparing the mean across two independent variables, allowing for the examination of intersection effect between them. So, what are the interacting effects between them? For an example, purpose of using two-way ANOVA is to access the impact of two factors on a dependent variable and understand if there is any interactions between the two variable or the two factors. For an example, investigating the effects of both teaching methods and student gender on performance score. Here you can see the technique or teaching of the method of a particular trainer, the different effect on performance of the student that they are scoring based out of the gender. So, the hypothesis testing applied over here. So, the null hypothesis states that there is no main effects of factor A and no main effect of factor B and no interactions effect. Alternative hypothesis states that at least one effect or interaction effect is significant. Assumptions of two-way ANOVA is the same as the one-way ANOVA, where the first one is normality and homogeneity and we have independence. Now we will talk about N-way ANOVA. What is N-way ANOVA? So, the N-way ANOVA is nothing but it generalizes the two-way ANOVA to any number of independent variable factors, whereas in the two-way ANOVA it was specified for only two, but in N-way ANOVA it generalizes for any number of independent factors. It is used to compare the means across the multiple groups defined two or more factors. What is the purpose of using N-way ANOVA? The purpose of using N-way ANOVA is to analyze the effects of several factors and their interactions on the dependent variable. For an example, examining the effects of diet like different types, exercises and the level of age group on weight loss, thus allows you to study the multiple factors and perform some operations. What is the hypothesis here? The null hypothesis states that the main effects or interaction effect. Alternative hypothesis states that at least one main effects or the interaction effect is significant. What are the assumptions of N-way ANOVA? The assumptions of N-way ANOVA is the same as one-way ANOVA and two-way ANOVA, where we saw normality, independence of observation, and the next thing is your homoscedasticity or else homogeneity, that is nothing but constant error variance. Next we have Manova. What is Manova? Manova stands for multivariate analysis of variance. So, if you want to define what is Manova, Manova is an extension of ANOVA test that allows for the comparison of multiple dependent variables simultaneously across the groups defined by one or more independent variable. Purpose to use Manova test is to access whether there is a changes in the independent variable having the significant effect on a set of dependent variable and to understand the relationship between them. Example, analyzing the effect of different teaching methods on student performance, motivation and engagement. Here, you can study how teaching method impact the multiple outcomes measures simultaneously. Hypothesis testing over here states, your null hypothesis states no difference in the mean of dependent variable across the group. Alternative hypothesis states at least one group differs in the mean of independent or dependent variable. What are the assumptions of using Manova test? The assumption of Manova or multivariate analysis are multivariate normality, homogeneity of covariance matrix, and independence of observation. What is the key difference of ANOVA test, Manova test, and two-way ANOVA test and n-way ANOVA test? So, firstly, let me talk about one-way ANOVA. There is only one independent variable, and if you want to talk about dependent variable, again there is only one dependent variable. If you want to talk about interaction effect, there is no interaction effect in one-way ANOVA test. In two-way ANOVA test, there is two independent variable and one dependent variable, and there is an interaction effect. In n-way ANOVA, there is three or more independent variable, one dependent variable, and yes, there is an interaction effect. In Manova, one or more independent variable, two or more dependent variable, and yes, it is an interaction effect if multiple factors occurs. When to use each of them? One-way ANOVA, comparing the means across for single factor. Two-way ANOVA, analyzing the effects of two factors or their interactions. N-way ANOVA, analyzing the effects of three or more factors and their interactions. Manova, analyzing the effect of factors on multiple dependent variables simultaneously. So, without further ado, we will start solving each and every question step by step. So, let me open my new notebook. Let me open new tab, Jupyter Notebook. So, let me copy my first question on ANOVA test. Let me copy it and let me paste my first question. So, what is my first question states? A researcher wants to compare the mean test score of the students from three different testing methods A, B, C. The data is as shown below. So, here you can see method A, that is 85, 88, 72 and 90 as the score, method B and method C. Now, they are asking to perform one-way ANOVA test, that is nothing but analysis of variance, to determine if there is a significant difference between the mean of the three groups. So, to check that, firstly what I want to do, I want to create this into a data frame. So, let me copy this same. Three methods, that is A, B and C. Let me change this as method A, that equals to this list of elements, that is 85, 88, 82 and 90, and method B, that consists of 78, 82, 80 and 85, and method C is equals to this information 92, 95, 89 and 91. So, now we want to perform a one-way ANOVA test here. So, to perform that one-way ANOVA test, what you can do, you can simply write it as F statistics, comma, p value, comma, is equals to, here the output you will get two different outputs. So, only I am loading two information, F statistics and as well as p value. So, before doing that, first let me start loading the library. So, import the necessary libraries from scipy.stats import f underscore one way. So now I will provide this f one way. Let me copy it. I will paste it here, f one way. I will write it as method A, comma, method B, comma, method C. So if I execute, so you got the output of f statistics and p value. Majorly I want to check with p value. Let me write my p value here. Print f statistics comma, that is nothing but my f statistics information, that is f underscore statistics. Let me copy this and then paste it here, and let me also print the probability value, that is p value. P value is equals to, comma, I will write as p underscore value. So I got two information, one is stress statistics and p value. So if the p value is less than the level of significance, you reject the null hypothesis, else you fail to reject the null hypothesis. So I can write a conditional statement in such a way that if p value is less than or equals to or less than level of significance, that is 0.05, then I am printing print reject the null hypothesis, that is nothing but there is a significance difference between the group. Your alternative hypothesis states that else you are going to print fail to reject the null hypothesis, right? Fail to reject the null hypothesis, that is nothing but no significance between the groups. So can you see here the p value is 0.0028, that means we reject the null hypothesis and we accept the alternative hypothesis, that is nothing but there is no significance difference between the group. So there is a significance difference between the group because we reject the null hypothesis, right? And we are accepting the alternative hypothesis. So now we will move on to the next question. So let me copy the next question and paste it. So this question states that a company tests the productivity of 3 machines X, Y, Z. The productivity scores are as shown in below. Perform a one-way ANOVA test to determine if there is a significant difference in the productivity or not. So how do I do that? Again, I want to use one-way ANOVA because I have only one samples or one certain set of groups. So let me write it down here. Your machine A is nothing but machine X is equals to 10, 12, 11 and 13. Let me copy and paste it here. And machine Y is equals to 9, 8, 10 and 7. Let me paste it here. And machine Z equals 15, 14, 16 and 17. Let me copy and paste it here. So now let me perform a ANOVA test. So same thing, F statistics comma p value is equals to, I want to write F underscore one way ANOVA. So in the one way ANOVA, I want to specify all the different machine analysis that we have taken. So machine X, machine Y, and as well as machine Z. So you will get the two parameters, one is F statistics and as well as p value. Let me print both. So instead of again manually doing, let me copy the above one and let me paste it. So always the condition remains same. If the p value is less than the level of significance, we reject the null hypothesis, else we accept the alternative hypothesis, else we fail to reject the null hypothesis, right? So let me run this. So again the p value is less than level of significance, that means we reject the null hypothesis and accept the alternative hypothesis. So therefore the significance, there is a significance difference between the groups. So now we'll move to the next question. So let me copy paste the question number 3. So here it states that a study compares the effectiveness of 3 diets D1, D2 and D3, no weight loss. So to check the weight loss, they are following the different diets, and based on that you want to say whether there is a significant difference between the different diets or there is no significant difference between the diets. So they have given the weights of each diet. Perform one-way ANOVA test to determine if there is a significant difference in the weight loss or not. To do that, what I can do? I can start creating a list of elements, that is D1, that is diet 1 is equals to, I will copy paste the list of elements 3, 4, 5, 6, and let me take it as D2, that is 2, 3, 4, 5, and D3, let me copy paste D3 here. So here is the 3 list of elements. Now I want to check whether there is a significance difference between the diets or there is no significance difference. So as I mentioned you before, you will just determine based on the p value, probabilistic value. If the p value is less than the level of significance, you reject the null hypothesis and accept the alternative hypothesis, and you state that there is a significance difference between the different groups. But alternative hypothesis is nothing but if your p value is greater than the level of significance, then you accept the null hypothesis. That means you fail to reject the null hypothesis. So at that particular time, you state that there is no significance difference between the mean. So before writing the condition, let me write as F statistics is equals to, and also I will write the p value equals F underscore one way of D1, comma D2, comma D3. So 3 different diets that we followed, we have mentioned that details. So let me copy paste the same principles that is present here. So there is no difference, just you want to perform small tweaks. So rather than writing difference between the groups, we can just write as difference in weight loss. Here also let me do the same thing, difference between in weight loss. So you can see here the p value is less than the level of significance. That is nothing but the p value is less than 5%. That means there is a significance difference between the weight loss. So now let me go for a fourth question. So here this states that a researcher compares the mean reaction time of participants under 3 noise level. One is low, medium and high noise level. The reaction time in seconds as given below. Perform one-way ANOVA test to determine if there is a significant difference in the reaction time. So again I will want to create a 3 list of elements. One is low. So let me copy this low factor and paste it here and mention medium. So let me copy the list of elements and let me paste it here, and then I, that is nothing but these are the I levels, right? Let me copy it and then paste it at the bottom. So now I want to perform the one-way ANOVA test. So F underscore statistics, comma, p value, comma, is equals to F underscore one way of low, medium and high, low, comma, medium and high. So I want to print the same F statistics and as well as this same information that is printed above. So let me copy it and let me print it here. So now if the p value is less than the level of significance, what you want to do? You are accepting the null hypothesis and rejecting the alternative hypothesis, and you state that if the p value is less than level of significance, you reject the null hypothesis and accept the alternative hypothesis. And we said that there is a significance difference in the rejection time. There is a significance difference in rejection times. So alternative hypothesis states that there is no significance difference between the rejection time. So now we can see here the p value again, it is less than level of significance. So you can easily state that we reject the null hypothesis and accept the alternative hypothesis, and we can say there is a significance difference between the rejection time. So we'll move to the last question. So the last question of ANOVA test, one-way ANOVA test. So here you go. It said that a researcher wants to compare the mean test score of the students from 4 different teaching methods A, B, C and D. The data is shown as follows. Method A 85, 82, 88 and 90. So these details as given. Perform one-way ANOVA test to determine if there is a significance difference between the means of 4 groups. If the p value is greater than the level of significance, use Stucky HST to confirm that which 2 groups are having the significance difference. So now let me start performing an ANOVA test. So to perform the ANOVA test, what you can do? You can just specify these details. Method A is equals to list of elements. Let me copy the list of elements and paste it here. Method B is equals to, again I will copy the other list of elements and let me paste it here. And method C is equals to, I will copy the next list of elements, I will paste it here. Method D is equals to the last list of element, let me copy it and let me paste it here. So I have printed the different list of elements. Now I want to perform the ANOVA test. So to perform ANOVA test, let me write as F F statistics is comma p value is equals to F underscore one way of method A comma method B comma method C comma method D. So, you are providing all the different methods. So, now let me print this statement. So, let me write as print both information. So, it is telling the p value is nothing but 0.017. So, again the p value is less than the level of significance. So, there is no significant difference, or there is a significance difference in the rejection time, because the p value is less than level of significance. So, we will move to the next question, that is by using the two-way ANOVA test. So, now if you also want to perform the Tucky HSD test, you can do it. So, to perform the Tucky HSD, what you can do? You can just write as data is equals to method A plus method B plus method C plus method D. So, you have provided all the four methods that is present above. So, now you can just write as a groups is equals to A into length of method of A plus index of B into length of method of B. The same thing I will do it for C and as well as for D. So, let me copy it. Let me write as plus this, right. So, let me change this B to, let me make it as B. So, from this let me change that A to C, here also let me change it to C, here from A to D, and let me change the method D. So, I have created four different groups. Now, I will perform Tucky HSD. Tucky results is equals to, first you want to load the necessary libraries to perform the Tucky HSD. So, let me load the necessary libraries here. From scipy.stats import F1 way, and also import the Tucky HSD, pairwise Tucky HSD from stats tools dot stats dot multicom import pairwise underscore HSD, pairwise Tucky HSD. So, now I have defined the pairwise Tucky HSD. I want to provide the details here. So, let me specify the details in such a way that pairwise Tucky HSD, let me copy this pairwise Tucky HSD, let me paste it here, and now let me provide the values, that is data comma groups that I have created comma alpha value. Alpha is equals to 0.05. So, this is successfully I have run. So, they are telling like no module or stats tools, that is fine. In the library that is telling like there is no module stats tools, that is nothing but stats models, not stats tools. Let me change this to stats models dot stats So in the second line, there is an error by stating that. Let me rewrite it from stats models dot stats dot multicom import pairwise HSD. So now it is working fine. So now we executed this HSD. So now we want to print the summary report of this HSD. So to print the summary report, you can just write as print result. So that will print you the results of the HSD. So this tells which two groups has the similarity or difference. So you can see here A and B. So it is telling the p-value here 0.092. That means it is rejecting the alternative hypothesis by stating that there is a difference or there is no difference between the two different scopes, that is A and B. That is false. There is no difference, that is nothing but it is accepting the null hypothesis, and it states that there is no difference between the A and B group. So A and C will compare it. So A and C also we see the p-value here. The p-value is greater than level of significance. That means we accept the null hypothesis and we state that there is no significance difference. A and D, again in the A and D also the p-value is 0.79. That means we accept the null hypothesis, or else we fail to reject the null hypothesis, and we state that we summarizes that there is no significance difference between the A and D. B and C, if you see B and C, the p-value is less than level of significance. That means we reject the null hypothesis and accept the alternative hypothesis, and we state that there is no significance, there is a significance difference between the two groups. B and D, again it is more than 0.05 or more than level of significance. So we fail to reject the null hypothesis and states that there is a significance difference. There is no significance difference. So let me clarify you once again. So you want to make sure that whenever the p-value is less than the level of significance, that means we reject the null hypothesis and accept the alternative hypothesis. If the p-value is greater than the level of significance, we fail to reject the null hypothesis. Got it? So null hypothesis is accepted in the sense then there is no difference. Null means there is no difference between the two different groups. Alternative hypothesis, there is a difference. So if you see A and B, so in the A and B you can see the p-value is greater than the level of significance. So it states that there is no difference between the two different groups. But if you see here B and C, so B and C where it rejects the null hypothesis and accept the alternative hypothesis, where it is telling true, that means there is a significance difference between the two different groups. So now we will talk about two-way ANOVA test. So let me print the two-way ANOVA test, and we have already discussed what is two-way ANOVA test and when to use two-way ANOVA test. So two-way ANOVA test is nothing but analyzing the effects of two factors and their interactions. So let me copy the question and let me paste it here. So what it is telling, they are asking me, a researcher studies the effect of teaching the methods of A, B and gender male and female on the test score. The data is as follows. Teaching methods of A, male is provided. Teaching method of A, female is also provided here. Teaching methods of B, male is provided the details, and teaching method of B with female details is available. So now we want to perform the certain operations. So first thing what I can do, I will create a data into the pandas data frame. So let me write as import pandas as PD. So I want to perform a two-way ANOVA here. So I am importing the OLX models as well. from stats models dot formula dot API import OLS. So now let me write down data is equals to, so this is the teaching factor data, that is, let me copy here. So let me mention all the information in the curly braces. So teaching method, what is the teaching method here? So the teaching method is, first time it is A and again A, and then we have B and then we have B. So A is nothing but A should be mentioned 4 times. And let me provide the details of let me copy paste the data once again. So A information, let me write it as here, test score. So let me convert it into data frame. So let me write as test score is equals to list of elements, that is nothing but 85, 88, 82 and 90. Let me copy paste it. This is your first test score, comma, and again I want to write down the other test score element, that is starting from 78, all the information. So let me print it here. Again I want to copy the next elements. So let me print it and then let me copy the other information. So let me print it here. So 1, 2, 3, 4. So I want to write 4 times A here again, comma, for this also it is A. So again next is also A information. So let me copy paste the same thing here. So next information is B. B is repeated again 4 times. So I want to do the same operation again. So let me copy it. 1, 2, 3. Okay, now I want to copy this entire thing. Let me paste it here once again. So B is created. So I want to do the next thing is your male and then your female gender. So comma, gender, colon. So list of element. So all the 4 males that we have here at the beginning, male, and then let me write as comma, and let me copy the same thing 2 times, 3 times and then 4 times. So let me copy this again because the next element is also a male category. So let me print it here, comma, sorry, the next category was female. Let me write it here, female here. Female, so 4 times female that we have, copy it. So let me write as female, female, female. So let me copy these details here at the last, and then I want to paste the female at the last. So this is totally working fine. So comma, I want to add this test score at the last. Let me add the test score as well. So this is totally fine. Now I have created the data set. Let me use colon. So data set is successfully defined. So data looks like this. So I want to convert this data into data frame. So pd dot data frame. I will provide the data information. So this is converted into data frame. Now I want to perform a one way ANOVA, two way ANOVA. So to perform the two-way ANOVA, what I can do, I can just simply define this into data frame df. So let me write it as model is equals to O less model with test score notation. You want to give note, you are specifying C of teaching method plus C of gender plus C of teaching method with colon C of gender. So data is missing. Let me provide the data information as well. Data is equals to df, that is defined, dot fit. So fit is a function. Let me fit the information. So test score is not defined. So let me provide the test score here. Test underscore score. Let me copy this test score and let me paste here. That is small s. Okay. So this is totally working fine now. So let me write as ANOVA table is equals to sm dot stats dot ANOVA underscore lm linear model. So I want to provide model comma type equals to 2. SM is not defined. Let me import the SM as well. So let me go here in the importing the library. So let me import SM as well from sk stats models dot API import or let me write just import stats model dot API as SM. So SM is now successfully defined. So let me run this. So it is telling something, there is a problem in the gender information. Let me cross verify. Test score, that is nothing but C dot test methods plus gender plus have not given the age group information. Let me write the age group as well. C of age group. So now what we are doing, we are just writing an ANOVA. So let me write it as ANOVA table is equals to sm dot stats dot ANOVA underscore lm linear model. So here let me specify the model comma type 2. So if I execute, this is successfully working fine. So now let me print the details. Print Two Way Anova and the results of it. So it is printing the Two Way Anova and the results. Let me print the results details. display the ANOVA table. So you can see the ANOVA table is successfully printed. So now what I can do, I can also print the condition by stating that whether the accepting the null hypothesis or rejecting the null hypothesis. So I am writing a conditional statement here. Alpha value I am giving it as 0.05, and now let me state if ANOVA underscore table, that is nothing but your PR, this is PR of F, let me copy this and let me paste it here. If this value of C of teaching method is less than the alpha value, if it is less than the alpha, what you want to do? You want to write it as print there is a significant main effect of teaching method. You are writing F, let me copy the same thing. If ANOVA test of PR is greater than F, and rather than teaching method, let me compare with gender now. So gender is less than the alpha value. So you want to write make sure that significant mean effect of gender, and let me make the same thing as if ANOVA table is greater than p value, and then instead of teaching method, let me change this teaching method to teaching method colon, I am comparing both here, teaching method colon C of gender. So now I am telling significance interaction effect between teaching method and gender. So this is successfully printing the results. So this is how you can utilize your ANOVA test to solve the certain operations. So let me solve the next question. So the next question states that a study examines the effect of diet type low caliber, low carb and as well as high carb, where we have two different types of effects that has been provided, and exercise level that is low and high on the weight loss, find whether it is an effective or not. So we have low carb and as well as high exercises details. So what I can do, I will create a data frame here again, data is equals to, I want to create in the dictionary format as I created last time. So now let me provide the diet type, that is nothing but, here I want to provide in the list of elements. So this is a low carb, let me copy this low carb, right? So let me provide. So how many times I want to print that? I want to print 1, 2, 3, 4, 4 times, right? So let me copy it and let me paste it, right, rather than printing it. So I have created low carb 4 times, and again we have low carbonates. So let me copy this entire thing and let me paste it here once again. So I want to do the same thing for high carb. Let me copy this. Let me write it as I curve, that is into 8 times I want to print. So again I want to write the quotation, rather than let me write in this way only. So let me copy this and let me print it. Comma 1, 2, 3 and 4. So I want to do the same thing 4 times again. So let me copy from here till the last. Let me print these details once again here. Yes. So this is done. So let me write the next information. The next information is low exercise and high exercise. So let me write as exercise level as low and high. Exercise level. So exercise level has two things, one is low and high. So first part is low. Let me copy the same and let me print it once again. 2, 3 and 4. So let me copy the entire thing. Let me first I want to make it as I now. So the next information is I. So let me copy the I information. So I is also 4 times. So let me print this low value. Let me copy this 4 times of low and then 4 times of I, comma, this is 4 times, and I is also, I want to print it as 4 times. Just let me copy it and I want to make sure that I is also printed 4 times. So this is for low and high level of exercises. So the last thing is your weight loss. Weight loss. So weight loss is nothing but, let me write it down in the list of format. So this is your first weight loss. Let me copy and paste it here, comma, second weight loss details is available. Let me copy and paste it here, comma, third weight loss details is available. So paste it here, and at last we have fourth details, just copy it and then paste it at last. So execute, this is totally working fine. So convert that into data frame. df is equals to pd dot data frame. So let me write as data. So this has converted into data frame. So now let me write it as model is equals to OLS of, I want to write the model details here, all the model details. So let me explain you the step-by-step model details, how you want to write down. First you want to write it down the weight loss details, that is your target, right? So copy this weight loss and not symbol, not of, write it down C, first column, that is nothing but diet type. Diet type plus C of the exercise level, just copy the exercise level, and plus C of both diet and type and as well as exercise level you want to write it now. Both diet type colon exercise level, C of exercise level. So let me print the exercise level. So let me close that and let me write down data is equals to df dot fet. So let me execute this. So this is totally working fine. So now let me make sure that writing a conditional statement by So before writing the conditional statement, let me print you the details how the model looks like. I'll print the model summary. This is your model summary. So you can just write as ANOVA underscore table is equals to sm dot stats dot ANOVA underscore lm linear model comma type 2. So this is working totally fine. Let me copy this and let me print these details. So this is totally working fine. This is your summary report. So the same way you can write the conditional statement as I printed above. So the remaining questions, take it as assignment. So now we'll move to the next topic. From Two Way Anova to, we'll take it as N Way Anova. So let me copy these details of N Way Anova. Let me copy all the details of N Way Anova. So what is the purpose of using N Way Anova? I already explained in this list. So N Way Anova analyzes the effects of 3 or more factors that is present. So this is this N Way Anova, N Way Anova. So let me keep it into formats. So now let me perform some operations. Whereas first you want to create a data, that is nothing but you want to convert everything into data frame. So to do that, take it as teaching method. Teaching method. So in the teaching method, we have multiple teaching method like let me copy this A. I will write as list of A. Let me copy this, comma. So let me print A 8 times. So this is your 4 times. Let me copy this and let me print the same thing here. Next, I want to do the same thing for B as well. So let me write down as B, comma. I will copy it. So B has copied 4 times. Let me copy it and as well as paste it here. So this is created now. So now teaching method is done. Let me write as gender. So male, let me copy the male details and let me write as first 2 arguments of male, comma. Let me copy those details. So let me copy the entire series of information here. So male is copied 4 times and we have females, that is also we have 4 times. Female. So female 4 times and then we have male 4 times and lastly we have female. Okay, this details is also added successfully. So now let me perform the age group. age group is equals colon. So let me provide the list of age group, that is nothing but the initially we have young, let me write as younger details, and as well as older details. So young details that we have here, let me copy it, young. So I want to write young 4 times, and then also I have old details, comma, old. Let me copy this details of old, comma, old, and old details is done. So I want to have again young 4 times and as well as old 4 times. Then we have old 4 times. Let me copy this old and let me print it as year. So this is done. Also, I want to see the total score. Let me write the total score as well. Total score colon. So list of total scores. So total scores is added here somewhere. So let me copy the total score here. So let me print the total score of all the game. Let me print this as well. Let me copy this. Let me print it and then let me copy this as well. Let me print it here. So this is successfully run. So now let me perform some operations. So as we performed before as well, so we do the same thing. Df is equals to pd dot data frame. So let me provide the data details, data. So my df is successfully loaded. So this is your data frame. So now let me copy the same thing that we have created here, OLS model. Let me copy this OLS model and then let me add it here. The OLS model. So firstly we have taken as test score. So let me copy the test score here. Rather than weight loss, we are writing test score, and then we are performing a teaching method. Rather than diet type, we are writing teaching method here. Along with that, we have gender. Copy the gender, and then we have age group. Copy age group and print the age group here. So compare teaching method with. So write it down plus because I want to compare here another groups. So I want to write plus teaching method. I am comparing with what? Teaching method I am comparing with gender. Let me add the gender. Let me copy paste the gender here. Teaching method with gender plus. I want to make sure that I am writing teaching method with age group. Teaching method with age group. That is available here. Plus gender with age group. Let me copy the age group. So, remaining things are same. So, let me execute this. So, this is totally working fine now for me. So, now I want to just write it as ANOVA underscore table is equals to sm dot stats dot ANOVA underscore LM models and as well as type 2. So, it is telling some warnings it has given, just skip that warnings. If you want to overcome that warning, just you can write from warnings import filter warnings, ignore the filter warnings, just you can specify this. If you execute this, the warnings will get removed, that is totally fine. So, now we can just display the information, display or print the ANOVA table. So, the ANOVA table is successfully printed. So, based on this you can write a condition. So, this is your final summary report of your Manova. So, you can solve the remaining questions that is available in the script file. So, now we will move to the next topic called Manova. So, when to use Manova? When you are analyzing the effects of the factors on multiple dependent variables, at that particular time you want to go for Manova test. So, now we will try to deal with Manova test. Let me go back to the script file. So, there is a question on Manova test, let me copy paste it. So, now in the Manova test, first try to import the necessary libraries from stats models. So, they are asking a researcher studies the effect of teaching method of A and B on both math score and as well as verbal score. The data is as follows. So, we have math score and as well as we have verbal score for teacher A, and as well as for teacher B we have math score and verbal score. So, we have two different or multiple information or multiple variable you are dealing with. So, if you have multiple dependent variable, you want to go for Manova. So, you can just write as from stats models dot multivariate dot Manova import Manova test. So, I have imported the Manova test. First, let me create a data frame. So, data is equals to, let me write it as teaching methods, that is nothing but teaching method. So, we have two different teachers, one is A and the other one is B. So, A has taught for all these 4 people. So, let me write A 4 times A. So, I want to write this 4 times comma A comma A comma A. So, 4 times is done. Now, again we have B trainer. So, write it as B comma B, B and B. So, this is done successfully. So, now we will try to talk about the marks that they have got, math marks and as well as verbal marks. So, math score, that is equals to, what is the math score they got? The math score they got 85, 88. So, let me copy this details of math score. This is their math score. Let me print the details of math score here, comma, and the other math score is 92, 95, 89, 91. So let me print both the details. So now we want to also specify the another test, that is verbal score. So here you go, print the verbal score colon. So provide the score of the verbals. So that is nothing but 78 to 85. Let me print the 78 to 85, comma 83 to 86. Let me copy and then let me paste it here, 83 to 86. So this is your data. So let me convert this into data frame. df is equals to pd dot data frame of my data analysis. So now let me print the Manova test. Let me copy this Manova. Let me write it as Manova is equals to Manova dot from underscore formula. You are writing your math score plus verbal score notation not teaching method. Along with that, you are also typing the data is equals to df. So now here you can specify result is equals to Manova dot mv underscore test. So if you want to see the details of Manova test, you can just write as print result. So that gives you the detailed analysis of Manova test. So this is how you can perform the various ANOVA test. So here I have shown the example of how to use your ANOVA test, one way ANOVA, two way ANOVA and n way ANOVA and as well as Manova test. Thank you.